This is a review of basic graphing of lines or linear equations from Algebra 1 last year. And so we have this standard form, we have this slope-intercept form, y equals mx plus b. M and b are just some numbers. So for example, we have here y equals 3x plus 4. 3 is the m and 4 is the b. And we have it in this slope-intercept form that you're supposed to know what it is. Again, slope-intercept form, F-O-R-M. Okay, so the slope-intercept form, the word slope means how much is the line going up or down, basically. Okay, so I'll explain more detail. The slope is how much the line is increasing, going up, or decreasing, going down in that direction, from left to right. So this is called the slope of the line. And we have like increasing slopes, decreasing slopes, which are negative, increasing slopes, which are positive, and then we have no slope, which are lines that are like, y equals 3. That would be a line up at y equals 3 straight across. That would be a horizontal line, right? And then we have lines that are not functions, that are like x equals 4, which would be an up and down line crossing the 4 on the x. Right here, right? All right, so let's take a look at this one. Let me erase this stuff a little bit, get it out of here. Looking at the first equation here, the slope is 3, which you could think about like a fraction, 3 over 1, and the y-intercept is 4. Y-intercept is 4 means it crosses the y-line at 4, which is right here on the y-axis. Okay, so if I make a point at the 4, kind of going to make it a little better than that, I suspect. It won't even let me change it. I guess not. That's interesting. Huh. Okay. It didn't want to let me erase it. All right, so at 4. Good, all right. So that's where it crosses the y-axis. This is the y-axis. This is the x-axis. This is the coordinate plane, the Cartesian plane. This is quadrant 1. It's a fourth of it. It's all the positives. The x is a positive over here. And the y is a positive over here because we're positive over and positive up. Okay? So I'm trying to get rid of this here. It won't let me. Okay. All right. I'm trying to undo some stuff here and it won't let me. All right. So I'll erase it. This is all of the, remember we have x's and y's. X is how much over and y is how much up or down. So this is my x. So for example, I'm going to show you, I have down here my 3 and 1. It means when you have that, the number in front of the x, it means that you're going to go up or down this number and over this number. So I'm going to go up because it's positive 3. I start at my y-intercept. That's a nice place to start. We already made it at 4. So we'll start at the 4 and we'll put our pencil or pen on the 4. And we're going to go up 3. 1, 2, 3. And over 1, positive 1. And it will be right here. And we can do that again. Up 3 and over positive 1. And in fact, we could go down 3 this way and over 1. We know that we're going to have a straight line, so these all should line up. Did I do that right? 1, 2, 3. Whoops. Go right there. Okay. All right. So if you line these up, you end up with this really nice line going. It doesn't want to go, does it? That's interesting. Okay. Well, I was going to make a line for you, but I guess I'm not allowed to. It just disappears. Yeah, nice video. Okay, I thought I would do this nice for you, but I can't even delete things. All right, so I'll just make a fake line as much as I can, going like this. Not very straight, but I'll do my best. There we go. All right, so this is the line. This is an increasing slope. It's going up when we go from left to right. And it crosses at 4, that's the y-intercept. So that's the easy way to graph a line. It goes forever in each direction. It goes through the first quadrant here. This is the first quadrant. This is the second quadrant. This is the third quadrant. And you must remember this is the fourth quadrant. Everything over here, x's and y's are positive, both of them. X's are negative here and y's are positive. Both x's and y's are negative in that quadrant, and x's, of course, are positive, and the y's are negative over here in the fourth quadrant. Okay, this is just a little tiny version, but this goes forever in all directions, flat. This is in slope-intercept form. The slope is up 2 over 1. The y-intercept is at -1. So I'm going to put a dot at -1 on the y. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1 the other way, down 2 over 1 the other way. This is a line. This is your line. This is the line that is represented by this equation. That graph of that line is that equation. Okay, it's an increasing slope, and yeah, y equals 2x plus 0. There was nothing there, so it's like a 0 y-intercept. Cross the y at 0, and then go up 2 over 1, up 2 over 1, up 2 over 1 from the 0. Up 2 over 1, down 2 over 1 that way, down 2 over 1, down 2 over 1 that way. So our line looks like this. See if you can make a straighter one than me. Okay. It's an increasing slope again. This will be a decreasing slope because it has a -2. -2 over 1. Look, there's no y-intercept there. That means that we're going to cross at 0. That means we're going to go down 2 over 1. Down 2 over 1. Down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Up 2. Up 2. This is a line that is going down from left to right. When we look at this thing from left to right, it's going down. When we looked at, yeah, okay. So, boom. There we go. All right. Next page. Boom. Slope of 1/2 and a y-intercept of -1. Up 1 over 2. Up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. Slope of 1/2. There's my line. Going up, increasing. Starting at -4. -4. Make a line. Up 3 over 5. It's all positive. Up 3 over 5. 1, 2, 3, 4, 5. Up 3 over 5. 1, 2, 3, 4, 5. Down 3 over 1, 2, 3, 4, 5. So this looks like this. They all should line up. If they don't, you did a point wrong. look at it again. That's how you can check yourself. Increasing slope. Y-intercept is -4. Y-intercept is 1/2, which is located right about here. Down 3/2. Down 1, 2, 3 over 1, 2. We got to go half on this one, don't we? Down 3/2. Down 1, 2, 3. Whole units over 1, 2. Whole units. Down, did I do that right? Down 3/2. 1, 2, 3. Yep, over 2. Down 1, 2, 3. Whole units over 2 whole units. Notice that our whole units going down were like half to half to half. And you could make your line, and you should probably do one up there too on the top. This is a decreasing slope. It's pointing down. It's going down from left to right. This is y = 0. So I don't see any slope here. We don't slope up or we don't slope down because y = mx plus b. We only have a b number. We don't have an x here. The b number is 0. The y-intercept is 0. And the slope is 0, meaning it's not going up or down at all. So we could actually make a line on the x-axis and say the x-axis is the line y = 0. Okay, guys? Should be easy for you, I hope. This is the standard form. It is the ax plus by = c form. You have an a, a b, and a c number. Here they're 2, 3, and 6. So you just need to get it so you can graph it. And one way to graph it is to put it in slope-intercept form to change the form. And another way is to remember that the slope is, I don't know, I never remember this. Let me see. Minus a over b, minus a over c. Let me see. Well, let's just change it first. So 3y equals, we're trying to get y alone because that's what we had before. Negative 2x, because we took off the 2x from both sides, plus 6, right? And then, so y equals, divide by 3, negative 2/3 x plus 6 divided by 3 is 2, right? I think. Okay, so this is our slope-intercept form. The slope is negative 2/3, and the intercept is 2. And it doesn't matter where that negative is. It could be down at the bottom or out front, okay, of the fraction. So notice that the slope, the slope, negative 2/3, is like negative a over b. If you look at those numbers, the slope is negative a over b. And I'll write it for you. Negative a over b is going to be the slope. So you could take the opposite of that number over that number, and that will be your slope. And the y-intercept is the same as the, let's see, b over c, negative a over b, a over c, 2/6, no, 6/2, 6/3, c over b, c over b number, which is 6/3 here, right? Which is 2. So that's your y-intercept, the c over b, and that's your slope. I'd forgotten, but I remember now. Okay? Yeah. So you can change the form. Sometimes we'll ask you, put this in slope-intercept form. And you have to. Because I'll give you standard form sometimes, which is the ax plus by = c. Okay? So you can just put it in slope-intercept form, or you could just remember negative a over b is your slope, and c over b is your y-intercept. Okay? So how would we do that here? Down 2/3, we start at 2. Go down 2/3, down 2/3, down 2/3. Oops. Yeah, something like that. Okay. what did we say? It's negative a over b and c over b. Sorry, negative a over b would be negative, is it in the standard form? No, it's not. Standard form has the x first, right? So the standard form here is negative, okay, it's negative 2x plus 6y equals 12. That is the standard form. And from the standard form, if I want to just use this, then I'm going to say negative a over b is the slope, but I need the y-intercept first. C over b is the y-intercept, which is 12 over the b number. 12 over 6 is 2. So we have a slope equals 2, and we have a y-intercept of a over b. No, I'm sorry. Wait a minute. We have a slope of something different. The y-intercept was the c over b. Y-intercept is the, y-intercept is the c number over the b number. Y-intercept is the 12 over 6. Y-intercept is 2. Not slope, my bad. Sorry. Y-intercept is 2. And slope, it won't let me delete it. Okay, so I'll try again. Erase. It keeps changing itself. I don't know why. Okay. Now I can write. Slope is, again, negative a over b. Negative 6 over negative 2 is positive 3. Okay? Again, you don't want to memorize these things like I don't. I just throw it into slope-intercept form whenever I can. But slope 3, y-intercept 2. Y-intercept 2. Slope 3, up 3. 1, 2, 3. Over 1. Up 3. Over 1. Always check to see if each individual is 1 or more, because sometimes somebody might trick you. These are. Each one is 1. Okay. Right. Yeah, I think that's, is it the last page? Or you got one more? Y equals negative x plus 0, for example, you could say. We just subtract x from both sides of the equation. So I've got a slope of down 1 over 1. You could think about down 1 over 1, for example, would work. You could put the negative anywhere you want. Start at 0. Down 1 over 1. It should be a positive slope or a negative slope? It should be a negative slope. Okay. So down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. You can see where it will line up and be a negative slope. Notice that that line divides the second and fourth quadrants into 2 equal parts. It's like got some symmetry there, all right? This is a complete diagonal line going down. This one has y equals negative x plus 1. We just subtract x from both sides of the equation. So start up at 1, down 1 over 1, down 1 over 1, down 1 over 1. It should be a negative slope because we have a negative here. Okay. Gosh, did we start the video over or something? Why is it at 1 minute? Oh my God, that's a long video. No way that it's that long. Okay. This is in some other form. Again, you don't have to watch the whole video. I don't care. This is in another form, which is called the point slope form. And point slope form says y minus y1 equals m times x minus x1. It just means that when you see it, y minus a number equals something times a parenthesis with the x in it. And that's what we've got here. Okay? That's exactly in a slope-intercept form. So if I have that, then it gives you the slope and the intercept, but I don't remember where. I always put it into slope-intercept form, not point-slope form. So you can change the form quite easily. That's one thing we can do. And I'll just delete this right now so I can do that. And we'll change the form. And it will mean that we have, it'll mean that we have y minus 3 equals 2x minus, I'm multiplying, I'm distributing, minus 2. Okay, we get the y alone, which is what we always want when we're graphing lines. That's one way. We can do it at least a very common way. Add 3 to both sides. Negative 2 plus 3, because we're adding 3 to both sides, is plus 1. So it's a slope of up 2 over 1, up 2 over 1. We start at 1. And we go up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. And our line looks kind of like that, right? Okay. Notice the slope is 2. The y-intercept here is 1. Okay, so next one. I'm in point-slope form. We could also think of the point-slope form, if I can show you this correctly. The slope is the change in y over the change in x. How much y changes for every change in x, in unit in x. So we can think about that. I'll show you that again in a minute. But we can think about that, and we need to be able to think about that when we're calculating slope looking at 2 points on a line. Let me demonstrate with something. Well, first let's change this to y equals, get rid of the 4, subtract the 4. Well, first we got 3x plus 3 times 5 is 15. And we need to get rid of that 4, so I'm going to put that, I'm going to minus 4 off over there. Y equals 3x plus 15 minus 4 is plus 11. Is that right? I think so. 15 take away 4, yeah. All right, it's 3x plus 11. Well, 11's way up here, so it's hard to kind of go that way, isn't it? On the graph, it's at the top. Up 3 over 1, up 3 over 1 is the same thing as down 3, 1 the other way. So I'm going to go down 3, 1, 2, 3. And it's a positive slope, so I know that my line needs to go upward. Down 3 over 1 this way. 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 This is my line. Now, if I give you a line with 2 points on it, you should be able to tell me what the slope is. So, for example, let's give you 2 points. If I said, here's a line, what's the slope of that line? Now, a line goes through those 2 points. I might even draw the line somehow. Boom, 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 boom. That's not a very nice line. And I say, what's the slope of that line? Imagine that's a straight line, please. Well, you need to say that I could do many things, but I could just go, oh, the slope is up 1, 2, 3 over 1, 2, 3, 4, 5. Up 3 over 5. Okay? The other way you're going to have to think about slope for other reasons, especially if you plan to do more math, is that the slope equals y minus y2 minus y1 over x2 minus x1. What does that mean? It means you need to take two of the y's, or you have a point. Let's call this y1, x1, y1. That blue point, well, that red point right there. And this point down here, we're going to call that x2, y2. That just means, it doesn't mean squared or anything like that. It just means, it's the second point, okay? So we take the y's from those 2 points and we subtract them. So if you look at the formula down here, it says y2 minus y1. So what's y2? It's how high is this point right here. And how high is that point? 1, 2. And how high is this point? 1, 2, 3, 4, 5. So we have to say the big number 5 minus 2. So we could do it that way. Let me write it. Boom. 5 minus 2. And on the bottom, we have the x's. So the x is how much over. So the x's are how much over. So I'm going to look at how much over I'm going this way to get from this point to this point. How much over is the difference between the 2 points. So 1, 2, 3, 4, 5. Okay, so that's what this is, 5. But, so we need to look at the x's, and we need to subtract them. So take the x from one of these and subtract the other one. We'll do this x because it's 2, right? The x is 2 for this point, and the x is negative 3 for this point. So if we said 2, because this is 2 over, if we said 1, 2, and I'm going to write the and this one is negative 3, like we said. So I'm going to say it, I'm going to write it, 2 minus negative 3, which is the 5. Obviously, when I give you 2 points on the graph, it's easier just to look at the 2 points and make your slope. But you need to know for later how to do this, which would give you 3 over 5. Okay, subtracting x's, subtracting y's. Y's are on top. Y's are how high? How high is on top? So y's over x's. Don't worry if that's a little fuzzy. We'll get to there again. Bye.